An AC voltmeter with a full scale range of 5 volts is used to measure the output voltage of an amplifier. So it is used to measure the output voltage across the amplifier, which has an output impedance of 2000 ohms, and the meter sensitivity is 2000 ohms per volt. This is important. The AC voltmeter has a sensitivity of 2000 ohms per volt. All right, got it. When connected to an amplifier, the meter reads 2.5 volt. So when the meter is connected across the amplifier, it reads 2.5 volts. Overwrite this thing right here, 2.5 volt. That's the voltage across the amplifier. Okay, all right. If a different meter with a sensitivity of 100,000 ohm per volt and a full scale resolution or full scale range of 5 volt connected to amplifier, find the voltmeter reading. So let's not worry about the last part. In order for us to find out the voltmeter reading, we have to first find out the value of the RM so that we can apply voltage divider here and find out the V out, right? So the first thing, the value RM of this resistor is just simply dependent upon the sensitivity of the voltmeter and the full scale range, which is 5 volt. So sensitivity is 2000 ohm per volt, correct? I'll just write down as 2K ohm per volt times full scale range, which is 5 volt. The volt and volt will cancel out, and RM is just simply going to be 10 kilo ohm, correct? Right? So if this is 10 kilo ohm, and remember this is the output across the amplifier, surely we can apply a voltage divider and find out V out. So V out is going to be equals to, in fact, I can rewrite this as V of M equals to V out times this reading, which is 2.5, or this voltage is the voltage across RM. Remember, the two are going to be in parallel. So the voltage RM is going to be same to that whatever the voltage here, correct? So V out times RM divided by the total resistance, which is R out plus RM, correct? This is almost a series circuit here, correct? We have current flowing in here and goes to the negative terminal. So R out plus RM. Remember here, our goal is to find out V out, correct? Our goal is to find out V out. So I can rearrange this equation such that V out equals to VM R out plus RM divided by RM. And if I plug in the values here, VM voltmeter reading is 2.5, correct? R out is 2K, RM is 10K, and then RM 10K here. So if I do the math here, V out is simply just going to be equals to 3 volts. Okay, this is going to be 3 volts. Now, a new meter with a sensitivity of 100,000 ohm per volt and a same full scale range of 5 volt is connected to the amplifier. Find the voltage here. Remember this RM, there's going to be a new value for RM because the sensitivity has now changed. So let's now calculate the new RM, which is going to be 100,000. So I'll just write down 100k ohm per volt times full scale R, which is 5 volt. So you get 5 volts here. This volt and this volt will cancel out. 100k ohm times 5 is going to give me 500 kilo ohms. Correct? 500 kilo ohms. Now I can just simply apply voltage divider again. Remember, this is almost a series circuit here. So 3 volt, again this Vm will equals to V out here, which is 3 volt time whatever the voltage across Rm, same voltage will be across the amplifier Vm, times what is the value of Rm? We just calculated, it was 500k. So you have 500k here divided by the total resistance, which is going to be the sum of these two, 502 kilo ohm. If you do the math, it will come down to 2.98 volts, approximately equals to 3 volts, and that is your answer.